In this video, I choose to give more examples on product and chain rules of differentiation. So let's go for more examples. Number one, if y equal to 2x minus 1 in a bracket against 3x minus 2 raised to the power of 5. So this is the kind of question that we will need to apply both chain rule and product rule, because we need chain rule to get this sorted out, and then subsequently we may apply product rule. So the solution will go this way. If u equal to 2x minus 1, and then the differential value of u is going to be 2. And the same thing, if v equal to 3x minus 2 raised to the power of 5, of course, uv, which is our product rule. Then differentiating v, this is actually where we need to apply. This is where we need to actually apply chain rule to solve this question. Okay? And then we have applying chain rule here will actually give us 5 in the bracket 3x minus 2 raised to the power of 5 minus 1, and then multiplied by the differential value of 3x minus 2, which is actually 3. So if we do this, the differential value of v, 5 times 3, that's going to be 15 in the bracket 3x minus 2 raised to the power of 4. And then we go for the y dx. Don't forget that the y dx is actually going to be what? The product rule of uv prime plus vu prime. I refer you to the last video I made on products and chain rules of differentiation part 1. Then I discussed extensively the product and chain rule there. Then let's apply this to get our answer. And then our u is 2x minus 1, okay, multiplied by v prime, and v prime is 15 against this, so it has to be 15 in the bracket 3x minus 2 raised to the power of 4. So let me put this in the bracket this way, plus, and then v is actually 3x minus 2 raised to the power of 5 times the differential value of u, which is times 2. And therefore, we can actually choose to write out, this one has become a coefficient of everything because everything is multiplication here. So we can choose to write it out this way, 15 in the bracket 2x minus 1, and then in the bracket 3x minus 2 raised to the power of 4, and then plus 2 bracket 3x minus 2 raised to the power of 5. And then something is common to this, and that is 3x minus 2 raised to the power of 4. So we can use that to factorize the whole expression there. And therefore this becomes 3x minus 2 raised to the power of 4, okay, in a bracket. And then this becomes 15 bracket 2x minus 1, and then plus 2 bracket. And then this one, we have one of it left after we use 3x minus 2 raised to the power of 4 to factorize. That's minus 2 and a bigger bracket. And then we have 3x minus 2 raised to the power of 4, okay, in the bracket. This times this, that's going to be 30x minus 15. And then we can use this to open up the bracket. That becomes plus 6x minus 4. Okay. And then we can actually rearrange and then to collect like terms inside the bigger bracket. And then this becomes 30x plus 6x minus 15 minus 4. Okay. And then the final answer becomes 3x minus 2 raised to the power of 4 in a bracket 36x minus 19. So this is the answer to the question we have here. Okay, then let's consider another example. Okay, another example, let me call it question 2. If I given y to be root x in a bracket x minus 3 raised to the power of 3. Okay, so in this case we have y equal to, we can actually interpret root x to be x raised to the power of 1 over 2 in a bracket x minus 3 raised to the power of 3. So this is the product rule. They will need chain rule to solve this. Okay, then we can go ahead and apply a product rule in which our u equal to x raised to the power 1 over 2, and then u prime is going to be 1 over 2 x raised to the power of 1 over 2 minus 1. So in this case, u prime becomes 1 over 2 x raised to the power of minus 1 over 2. And we can actually analyze this very well. So in such a way that becomes 1 over 2 times 1 over x raised to the power 1 over 2. Okay, and this becomes this times this, that's 1, that's numerators multiplied by itself, over 2 x raised to the power of 1 over 2, which eventually becomes 2 root x. Okay, so let's keep that there. And then our v, of course, our v is x minus 3 raised to the power 3. So v is x minus 3 raised to the power of 3. So v complement, that's going to be, we need to use chain rule, and chain rule is this, 3 multiplied by x minus 3 raised to the power 3 minus 1, and then multiplied by the differential value of x, and that is 1 times 1. So eventually we have v prime to be equal to 3 in the bracket x minus 3 raised to the power of 2. So we need to go ahead and find the y dx. So the y dx equal to uv prime plus vu prime. okay, and then this gives us the u itself is x raised to the power 1 over 2, okay, multiply v prime is actually 3 in the bracket x minus 3 square, and then plus v is x minus 3 cube, okay, and then multiply by u prime. Don't forget that u prime gives us 1 over 2 root x, so this is 1 over 2 root x. So we need to actually refine what we have here, and therefore we can make use of x minus 3 to factorize, since it's common to this side and this side. So if we make use of that to factorize, we have x minus 3 squared, okay, in the brackets. X, this has become 3 times this. That is 3x raised to the power of 1 over 2, okay, raised to the power of 1 over 2 there, plus, and then this, out of this, we have 1 left, times this. That's becoming x minus 3 over 2 root x, okay, and then we can press forward. This x minus 3 squared in the brackets. This is 3x raised to the power 1 over 2, okay, and then plus x minus 3 over 2 root x this over 1. And then we can harmonize this as a common fraction. So if you harmonize that, we get x minus 3 squared in a bracket. The LCM here becomes 2 root x, okay? So this one becomes everything here times 3x raised to the power 1 over 2. Don't forget this one is also root x. So this is becoming 6x, okay? 6x, okay? And I can actually show you that there. Then what I just did there is 3x raised to the power 1 over 2 times 2 root x. Don't forget this one is 3x raised to the power 1 over 2 times 2x raised to the power 1 over 2 as well. 3 times 2 here, that is 6, okay? And then times x raised to the power 1 over 2 plus 1 over 2. And then this is 6 times x raised to the power 1, because 1 over 2 plus 1 over 2 is 1. So that's 6x. So that's how I obtain my 6x, okay? And then that's 1 into this itself, then times this. That's that. And then this into this is 1 times this. That's plus x minus 3 times 1. And then we can take it further, okay? If we take it further, we have this. So I take it off from where I stopped there. And then we have x minus 3 squared, okay, x minus 3 squared in the bracket, and then 6x, okay, let me open up the bracket there, 6x plus x minus 3, everything over 2 root x, okay, and then we have x minus 3 squared in the brackets, and then this one can be added together, so we have 7x minus 3 over 2 root x, okay, and then we can actually choose to stop it, but at the same time the answer can still be solved further, but we can actually choose to stop it. So that is the answer to this, okay? But if we choose to solve it further, we can actually go further. That means we'll need to separate this, and if we're separating that, we have to do this one, that is x minus 3 squared in the bracket. This one becomes 7x over 2 root x minus 3 over 2 root x, okay, and then here can be x minus 3 squared, okay, x minus 3 squared in the bracket. This one is 7x over 2 raised to the power of x, 2x raised to the power 1 over 2 minus 3 over 2x raised to the power 1 over 2. I just decided to interpret root x as x raised to the power 1 over 2. And therefore, this is x minus 3 squared in the bracket. Okay, this is 7 over 2. We have 7 over 2 here. Okay, this is x raised to the power 1 divided by x raised to the power half. It can be x raised to the power of 1 minus 1 over 2. Okay, minus, then this one can be 3 over 2x raised to the power 1 over 2, okay, and then this is, we can actually use 1 over 2 here to factorize the whole expression. So let's write that out. This is 1 over 2, so that becomes x minus 3 squared, okay, in the bracket. Then we have 7 here, x, 1 minus 1 over 2 is 1 over 2, minus, this is actually 3 over x raised to the power 1 over 2 this time around, and therefore a final answer 2 can be this x minus 3 excuse me, x minus 3 squared in the bracket. Then this one is going to be 7 root x minus 3 over root x. So the answer can also be presented this way, and it can be left like this. Anyone is correct. So depending on what your teacher wants you to do. Then let's move on to question 3. Question 3 says y equal to x squared in the bracket 2x minus 7 raised to the power of 5. Okay, this is also the combination of product rule and chain rule to sort this question out. Our u, of course, is going to be x squared, and then differentiating u is going to be 2x, and then our v is going to be 2x minus 7 raised to the power of 5, and then v prime is going to be, the chain rule is going to be involved, 5 multiplied by 2x minus 7, and then times the differential value of 2x minus 7, which is 2. That's chain rule there, and then v prime is going to be 5 times 2, that's 10, and the bracket 2x minus 7, okay, raised to the power of, oh, sorry, I made a mistake here. This one should have been raised to the power of 5 minus 1. So this one is now raised to the power of 4. Okay, and then we go ahead and apply our product rule. And the product rule here is going to be, the product rule there, it is going to be the y, the x, divided x equal to uv prime plus vu prime. Okay, and then we go. This is going to be u itself is x squared, okay, multiplied by 10 and the bracket 2x minus 7 raised to the power of 4, and then plus, okay, v itself is 2x minus 7 raised to the power of 5, okay, multiplied by u prime, that's 2x. So we can put it up that way, and then that means we have 10x squared here. So this x squared times, that's the dot product of 10 and x squared, that's 10x squared, okay, in the bracket 2x minus 7 raised to the power of 4 plus 2x bracket 2x minus 7 raised to the power of 5. Okay, and then we can actually use this 2x minus 7 raised to the power of 4 to factorize the expression. So this becomes 2x minus 7 raised to the power of 4. Okay, in the bracket, that means we have 10x squared left here plus 1 of this, that's times 2x bracket 2x minus 7. Okay, then we can use this to open up the brackets. Then this becomes 2x, excuse me, this becomes 2x minus 7 raised to the power of 4 in the bracket. This is 10x squared plus 4x squared. If you use this to open the bracket, plus times minus there remains minus, that's 14x. Okay, and then we still go ahead, we can still solve it further. Okay, and this becomes 2x minus 7 raised to the power of 4. Okay, in the bracket 10 plus 4, that's 14x squared minus 14x. Okay, this looks interesting in the sense that we can actually use 14x to factorize this. So if you use 14x to factorize that, we can just choose to write it out, okay, completely. That's 14x here. Okay, let me write my one again. That's 14x, okay, in the bracket 2x minus 7 raised to the power of 4. This divided by this, so we left with x minus 1 on this side. So this is the correct answer to the question we just solved. Let's go for another example. Okay, another example, that should be my number 4. My number 4 is we are asked to find the y dx if x squared minus 1 in the brackets, okay, that's square root of x squared minus 1 in the bracket root of x plus 3, okay, equal to y. So we have to find the y, the x. Okay, so this is also a combination of product rule and chain rule. Okay, all right, let's go ahead. Our u can be x squared minus 1, okay, raised to the power of 1 over 2. I choose to interpret root of x squared minus 1 this way. Okay, that means the u prime is going to be, we need chain rule to get this done, and that's going to be 1 over 2 and a bracket x squared minus 1 raised to the power 1 over 2 minus 1, okay, times the differential value of x squared minus 1, and that is 2x. Okay, so this becomes 1 over 2 in the brackets x squared minus 1. 1 over 2 minus 1 is actually negative 1 over 2. Then times what? Times 2x. Times 2x. Okay, and then we can solve further in the sense that this can be 1 over 2 times 2x times in the bracket on x squared minus 1 raised to the power of 1 over 2. So this can get rid of this. And then the differential value here can be x times, and of course this can be 1 over x squared minus 1 raised to the power of 1 over 2. And then this can be x times this, if this is over 1. So it's going to be numerator multiplied by itself. Okay, numerator times numerator here is x here over x squared minus 1 raised to the power of 1 over 2. And then that aside, how about our v? So we need to write out the interpretation of v we have there. Okay, so if u complement equal to this, okay, and then v is equal to x plus 3 raised to the power of 1 over 2, and then v prime is equal to, that means this one has to be 1 over 2 in the bracket x plus 3 raised to the power of 1 over 2 minus 1, there, 1 over 2 minus 1, okay, then multiplied by the differential value of x plus 3, which is differentiating x. This is going to be 0, that's times 1. Okay, and then the v complement becomes that should be 1 over 2, okay, in the bracket x plus 3 raised to the power of minus 1 over 2. And then if you just write this very well, 1 over 2 times this one becomes 1 over x plus 3 raised to the power of 1 over 2. So if you multiply numerators against numerator, we have 1 over 2 bracket x plus 3 raised to the power of 1 over 2. And then we can go back to our product rule. So our dy dx now equal to uv prime plus vu prime. Okay, this is v, not u. Therefore, our dy dx equal to, so we need to bring up our answer for v complement and u complement, and then multiply by u and then multiply by v here. So this is going to be x squared minus 1 raised to the power of 1 over 2, okay, multiplied by 1 over 2 raised to the, bracket x plus 3 raised to the power of 1 over 2 plus v. Our v, don't forget that our v is our v is x plus 3, okay, raised to the power 1 over 2, okay, multiplied by x over x squared minus 1 raised to the power 1 over 2. And then we need to be very careful in sorting this out. And this becomes, of course, this times this can actually be written as x squared minus 1 raised to the power 1 over 2, everything over 2 in the bracket x plus 3 raised to the power 1 over 2 here, plus, and of course this times this, it can be written as x in the bracket x plus 3 raised to the power 1 over 2 over x squared minus 1 raised to the power 1 over 2, okay? And therefore, this actually looks alike, okay? So we can actually combine this or harmonize these fractions there. So if we harmonize these fractions there, we can get to have, this becomes 2, okay? I want to find out the LCM there. Okay, the LCM can be 2 in the bracket, then I want to write this one as square root of x plus 3, okay, and then against bracket square root of this of x squared minus 1. So this can be the LCM of your common fractions that you have there, and then this into this, into everything. That means we have this one times itself, you understand, and then this times itself is going to give us basically x squared minus 1, okay, that is x squared minus 1 raised to the power 1 over 2 times x squared minus 1 raised to the power 1 over 2. So we basically need to add 1 over 2 plus 1 over 2 here together to make it 1. So we have this, and then plus, okay, this get rid of itself. So we have this one times this, and this is 2 times x is going to be 2x, and then this multiplied by itself there is going to give you ordinary x plus 3, okay, because here is 1 over 2 plus 1 over 2, and that's going to be 1. And then we can press forward and sort that out. That means we have x squared minus 1. If you use this to open the bracket, you have plus 2x squared and then plus 6x, and then everything over 2 in the bracket x plus 3 or square root, and then against x squared minus 1 square root of that. And then we can express our final answer as x squared plus 2x squared. That's going to be 3x squared, and then plus 6x, and then minus 1. Everything over 2 in the bracket root of x plus 3, okay, in the bracket root x squared minus 1. So that is the answer to this kind of question, okay? And then let's look at another example. Let's look at another example there. This is I call this one question 5. This is question number 5. This is x cubed in the bracket 2x plus 5 raised to the power 3 equal to y. So the question actually asks us to look for the value of the y, the x. Okay, so we can write it out this way: x cubed in the bracket 2x plus 5 raised to the power of 3. So our u is x cubed, and then u prime is actually 3x squared. Okay, so our v is 2x plus 5 raised to the power of 3, and then v prime, it's actually 3 multiplied by 2x plus 5, and then raised to the power of 3 minus 1 times the differential value of the content of the bracket, which is 2, and therefore v complement, okay, is equal to 3 times 2, and of course it's 6 in the bracket 2x plus 5 raised to the power of 2. So this is 3 here, and therefore we apply our product rule. The y dx equal to uv prime plus vu prime, and therefore this becomes x cubed multiplied by 6 plus v complement in the bracket 2x plus 5 raised to the power of 2 plus 2x plus 5 raised to the power of 3 multiplied by 3x squared, and therefore this times this is 6x cubed in the bracket 2x plus 5 raised to the power of 2 plus this times this, that's 3x squared in the bracket 2x plus 5 raised to the power of 3, and therefore this can be 3x squared can be used to actually factorize this, okay? And then if we use that to factorize that, we have 3x squared in the bracket 2x plus 5 raised to the power of 2, and then in the bigger bracket I've actually seen 3x squared is a factor of 6x cubed here, so I use this to factorize this and one of them, so I'm opening the bracket there, so 6x cubed divided by this, so we're left with 2x there, okay, plus 2x squared plus, and then we're left with one of these, 2x plus 5 this way. I hope you understand. I hope my viewers understand why I'm doing here, like 3x squared here and 6x cubed here, so we can use this to factorize that, and one of 2x squared plus 5, 2x squared plus 5 raised to the power 3 here, we use this, and then it becomes everything here into this, so we're left this x, and then plus, okay, and then this gets rid of this, so we're left with one of that, and therefore what we have left here is 3x squared in the bracket 2x plus 5 raised to the power of 2, and then the bracket 2x plus 5, and then we have 3x squared in the bracket 2x plus 5 raised to the power of 2 in the bracket 4x plus 5. That is the answer to that question. So I'd like us to look at another examples so that we can fully understand the concept of products and chain rule of differentiation. So let's take a look at another example. Here is another one. We have, I think that's going to be my number 6. If y equal to square root of 16x raised to the power of 4, okay, root of 16x raised to the power of 4, root x plus 4. And then the question is to find the y, the x of that. So if it has to find the y, the x, so we need to do it this way. Our y can be square root of 16 is 4. Square root of x to the power of 4 is actually x squared multiplied by x plus 4 raised to the power 1 over 2. So this is actually the right interpretation of what we had there. So if our u equal to 4x squared, and the u prime, it's going to be 8x. And then if our v is equal to x plus 4 raised to the power 1 over 2, and then v complement is going to be, we need to use chain rule to sort this thing out. That's 1 over 2 in the bracket x plus 4 raised to the power 1 over 2 minus 1 times the differential value of the constant of the bracket, that is times 1, differentiating x, differentiating for the 0. And therefore, the v prime is going to be 1 over 2 times, this one is x plus 4 raised to the power minus half. That's 1 over 2 minus 1, and then times 1. So the v prime here is 1 over 2 times 1 over x plus 4 raised to the power 1 over 2. So v prime here, 1 times 1, 1 over 2, bracket x plus 4 raised to the power 1 over 2. And therefore, this can as well be expressed as 1 over 2 root x plus 4. That can be expressed that way. And therefore, we need to apply our product rule. The y, the x, equal to uv complement plus vu prime. And therefore, this is going to be 4x squared if I substitute all the values of u and v prime into the expression there, okay, multiplied by 1 over 2 root x plus 4 plus this one is going to be x plus 4 raised to the power of 1 over 2 times 8x. And then here becomes this times this, that's going to be 4x squared over 2 square root of x plus 4 plus, then this one becomes 8x in the bracket x plus 4 raised to the power of 1 over 2. And then we can actually use this to reduce this. And therefore, what we have left there is 2x squared over square root of x plus 4 plus 8x bracket. We can actually write this as root x plus 4 and then probably over 1. And then we can choose to harmonize our fractions there that we have, in which the LCM becomes square root of x plus 4. That place. So if the square root of x plus 4 is the LCM, so this into this, that gives you 1. So that means this one is going to be 2x squared plus 1 into this is itself, then times this. So what we have here is 8x in the bracket x plus 4. Okay, that is x plus 4 raised to the power 1 over 2 times x plus 4 raised to the power 1 over 2. All you need to do is just add x plus 4 raised to the power 1 over 2 plus 1 over 2. So it becomes x plus 4 raised to the power 1, which is the same thing as x plus 4. So this is literally the answer, but we can take it further. Okay, so if you take it further, just for us to have an answer expressed in its simplest form. So I'm going to write it out this way, like 2x squared plus, so when you open up the bracket, you have 8x squared plus 32x, everything over square root of x plus 4. And therefore, we can add up. This becomes 10x squared plus 32x, everything over square root of x plus 4. And then you can still use 2 to factorize, or 2x to factorize the numerator. So this is going to be 2x in the bracket, 5x plus 16, everything over square root of x plus 4. So this is the answer to that question. So let's take a look at another example. If we have this is going to be my number 7, y equal to 2x squared minus 3 raised to the power of minus 2 over 5. So in this case, I think chain rule will be applicable. So we have to find the y, the x. So if you use chain rule here, you simply have, okay, using chain rule, that's minus 2 over 5 and a bracket 2x squared minus 3 raised to the power minus 2 over 5 minus 1 times then the differential value of the content of the bracket, and that becomes 4x. So basically what we have here is minus 2 over 5 times 4x in the bracket 2x squared minus 3 raised to the power of minus 2 over 5 minus 1, and of course that's minus 7 over 5. And therefore we can get to write this as minus 8x over 5 in a bracket 2x squared minus 3 raised to the power of minus 7 over 5. And of course, this can still be written as minus 8x over 5 times this can be 1 over 2x squared minus 3 raised to the power 7 over 5. And therefore, the numerator can multiply another numerator there. So we have minus 8x, everything over 5, in the bracket 2x squared minus 3 raised to the power of 7 over 5. Or the answer can be written as minus 8x over 5 in the bracket 5th root of 2x squared minus 3 raised to the power of 7. So either this or this can be expressed as the answer to that question. So let's go for another example. Let's go for another example there. And then that should be my question number 8. In this case, we have y equal to 4x squared minus 3x raised to the power of minus 3 over 4. This is another example of chain rule. Okay, so we have to find the y, the x. Okay, so find the y, the x. Okay, so applying chain rule. Don't forget your chain rule says that the y, the x equal to n for the bracket u raised to the power of n minus 1 multiplied by the differential value of your u. And that's exactly what I'm going to do there. So the y, the x equal to the power here, which is n minus 3 over 4. So that becomes minus 3 over 4. Then in the bracket 4x squared minus 3x, and then multiply by differentiating the content of the bracket, which is u prime, and that is 8x minus 3. And therefore, this can be written as minus 3 over 4 multiplied by 8x minus 3. Okay, then the bracket 4x, oh, pardon me, I was supposed to write minus 3 over 4 minus 1 here. I forgot that. So this is going to be 4x squared minus 3x raised to the power of minus 3 over 4 minus 1. That becomes minus 7 over 4. Okay, and therefore, this is going to be minus 3 and the bracket 8x minus 3 over 4 here, then times this can be written as 1 over 4x squared minus 3x raised to the power 7 over 4. And of course, everything can be used to multiply itself here, and this one becomes of course we can use this 3 to open up the bracket, so this becomes minus 24x plus 9 times this becomes itself over 4 times everything at 4 in the bracket 4x squared minus 3x raised to the power of 7 over 4. Okay, and basically this is the answer to this kind of question. Thank you. Kindly subscribe to my YouTube channels.